What's up, guys? Andrew Steinmetz, QA/QC Manager with Genco Inc. Coming to you today with my latest video. This is the third video in my three-part series on motor calculations for the electrical exam. Please make sure to watch the first two videos on parts 1 through 4 before getting into this video. You will need those parts to complete this part. So please go back, watch those videos, and then watch this one. So as always, get your code book out and follow along. Learn where these tables are and calculate these for yourself to help you with the electrical exam. So let's just jump right into steps 5 and 6, tables that will be covered. Step 5, find feeder wire ampacity, section 430.24. Step 6, find feeder breaker size, section 430.62a. Article 430.24, several motors or a motor and other loads, conductors supply several motors or motors and other load shall have an ampacity not less than the sum of each of the following. 125% of the full load current rating of the highest rated motor as determined by 430.6a. Sum of the full load current ratings of all the other motors in the group as determined by 430.6a. So basically what you do is you find the largest motor size, you times that by 1.25%, and then all the other ones you add in. So let's go into step 5. This is step 3 plus all other motor FLC. Take the largest FLC, step 1, of all the motors and multiply it by 125%, and then add all the other motors FLC to it. FLC, largest motor, times 125% plus all other motors equals feeder wire ampacity. So let's jump right into a sample question. What is the feeder ampacity of a 5 horsepower and a 3 horsepower and a 2 horsepower 230 volt single phase motor? So first thing we want to do is we want to go to 430.248. We go to 230 volt single phase motor. We go down the line and we find that the 5 horsepower is 28 amps. Then the 3 horsepower is 17 amps and the 2 is 12 amps. So the largest is the 5 horsepower equal 28 amps. So you take the 28 amps, times it by 125%, 28 times 1.25 equals 35 amps. And you see here 125% of the highest rated motor. So then what we do is we take that 35 amps plus 17 amps plus 12 amps, and that's going to give you your answer, and that's 64 amps. Let's do another one. What size copper feeder wire with THHN insulation will be needed for a 2 horsepower and a 7.5 horsepower 230 volt single phase motor? So again, we go to 430.248. We go down the line. A 7.5 horsepower is 40 amps. Then the 2 horsepower is 12 amps. So the largest is a 7.5. And that equals 40 amps. 2 horsepower equals 12. So 40 amps times 1.25 equals 50 amps. Then we get 40 amps times 1.25 equals 50 plus 12 amps. That gives you 62 amps. So then what we want to do is we want to go to table 310.16 for wire ampacities. We find THHN right there in that third row. We go down, we see that an 8 gauge only handles 55 amps. So we need to go up to the next size, which is a 6 gauge. So that is the answer. So it's going to be a 6 gauge THHN copper conductor will be needed. What is the feeder ampacity of 2 10 horsepower 3-phase 230 volt motors, 1 3 horsepower 120 volt single phase motor? Use 430.250. we see that that is the 3-phase motors. And so you go down to 10 horsepower, and that gives you an answer of 28 amps. Then we go to the 3 horsepower in single phase, and that's on table 430.248. And we find that that's 34 amps. So number one, the 3 horsepower equals 34 amps, largest motor. The 2 10 horsepower equal 28 amps each, all other motors. So it's 34 amps times 1.25 equals 42.5 plus 28 amps equals 98.5 amps. Now you got to be careful and watch out for this. Just because it has a bigger horsepower doesn't always mean that it needs more amps or has more amps. Step 6, feeder breaker size. This is step 4 plus all other motors FLC. Take the largest branch circuit breaker protected motor and add all other motors FLC to it. Largest breaker size plus the FLC, all other motors equal feeder breaker size. So you're going to see right here on 430.62, a feeder supplying a specific fixed motor load and consisting of conductor size based on 430.24 shall be provided with a protective device having a rating or setting not greater than the largest rating or setting of the branch circuit, short circuit, and ground fault protected device for any motor supplied by the feeder, based on the maximum permitted value of the specific type of a protected device in accordance with 430.52 or 440.22a. For hermetic refrigerant motor compressors plus the sum of full load currents in all other motor groups. So let's go on from there. So 240.6a, standard, you're going to need this one, the standard amps for breakers or fuses. So what you see here is the 15, 20, those are the standard breaker sizes. What size feeder breaker is needed for a 5 horsepower, a 3 horsepower, and a 2 horsepower 230 volt single phase motor using time delay fuses? So we use table 430.248. We find the largest motor is the 5 horsepower equaling 28 amps. All other motors, 3 horsepower equals 17 amps, 2 horsepower equal 12 amps. Now what we want to do is go to 430.52. We look for time delay fuses, single phase motors, and then we go over there and we see it's timesing it by 1.75 or 175%. So 5 horsepower equal 28 amps. So 28 amps times 1.75 equals 49 amps. So you go with the standard breaker size of a 50 amp fuse. So then you take the 50 amp fuse plus 17 amps plus 12 amps, that's 79 amps. So if you remember what we read in the previous table or article is that for the feeder size cannot exceed the branch circuit ampacity. So we must go down in fuse sizes for feeders. So we need a 70 amp fuse. And that's it, guys. That's how easy step 6 is. So I hope all this helped you guys, and I hope this really helps you when you're dealing with the motor control calculations on the electrical exam. And I look forward to seeing you on my next video. All right, thanks.